Hi everybody and welcome to my presentation on how does physics impact me for my calculus-based physics class. So we'll talk a little bit about my car. I depend on my car to get myself to and from work every day. I need to arrive at the office on time. I get in very early because I work for a bank that's headquartered back in Toronto. I need to get to work early in the day. I also need to leave work on time to get to Santa Monica College. I depend on that for my car to get me from my home to my office, to my class, and back home. So this is a this is a map of my commute. So I travel from Pacific Palisades all the way along the Pacific Coast Highway, and then I get onto the 10 freeway, and I travel along the 10 freeway down to downtown Los Angeles. And as far as Google is concerned, that commute is 18.5 miles. You can see that number right there. So that is on the road, 18.5 miles as far as Google is concerned. Okay, I started this experiment at 5:57 in the morning. There's the clock in the kitchen. Here I am going outside to my car. See, it's dark out because it's very early in the morning. And I'm going to use the odometer in my car and the clock in my car to take the readings that we'll look at in this experiment. So you can see, you can see right here that we start out with the car having traveled 76,912.3 miles. There's something called 340 miles to empty. We'll come back to that later. And in a moment, we're going to move over to the clock, and you can see it's just a little bit before 6 a.m. So here we are, a couple of miles down the road. This is me at the Pacific Coast Highway. I want to make sure my professor understands I did no videoing while the car was moving. This is only to take a reading while the car is stopped. We've traveled just about 5 minutes to get to this point. Okay. And here we are at the garage. So 76,930 miles, 0.6. You can see there's the garage where I park my car. And the time is going to be shown in just a moment. And we are moving over to the clock right about now, just any second. And you can see that it is almost exactly 6:30, just about 6:31. So it took us about half an hour to get to work. Okay. Now here we are back in the afternoon. So I'm heading back to Pacific Palisades. It's just a little bit before 5 o'clock. We're still at that 76,930.6 miles. We've got 324 miles to empty. Here we are, just about, we've gotten off the 10, we're on PCH, so again, just stopped for a moment before we go up into the Palisades. So this is just another reading we've taken while the car is stopped. So you can see that we're now at 5:23 in the afternoon. This is another stoplight, again, just before we get up to PCH, to the Palisades. Okay, and now this reading right here, 76948.8. We are back at home. You can see the pumpkins ready for Halloween. So we have completed our trip. You can see that there's 313 miles to empty, which tells us how much gas the car thinks it has. So 776,948.8. And you will see that the time is exactly 5:30 p.m. Okay, back to the presentation. So I put a little table together that summarizes all the data we just had. So up on top, you've got the trip that we took to LA, readings at home, at that stoplight that we went to, and then the parking lot. You've got the different times. Then you've got the deltas in each of the times. You've got the readings on the odometer, deltas on the distance traveled. And then also, we'll talk a little bit about that later, but that's the miles empty. Same thing down here with times and readings off of the various measurement devices we have on the dashboard. Now, I want to talk for a second. Remember that this is my commute. So we drive all along this blue, red, and orange line to get from here to here. That is, as we said earlier, 18.5 miles or so. But I found a calculator on the internet that was provided by meridianoutpost.com, and that allowed me to put the latitude and longitude of home and the office in, and it gives us the exact distance as the crow flies. So even though we've traveled 18.25 miles, that's the average of the two trips we took, the displacement is 15.38 miles. We'll look at that again when we see the calculations. So here's all the math. X final is 76,930. This is in the morning. This is where we end up. This is where we started, 76,912.3. The change in X is 18.3 miles over 31 minutes. We look at our velocity over, which is the change in distance divided by time, gets us to 57 kilometers per hour. But if we look at the velocity based on actual, we traveled at 47.91 kilometers per hour. And that's due to the fact that we haven't actually, from a displacement part, traveled quite as far. We took kind of a circuitous path to get things. In the afternoon, just change in distance of 18.2 miles, 42 minutes, reflecting the fact there's more traffic, there's more people on the road at that time, so it took us a longer time to get home. And so in that case, we traveled 41.84 miles per 41.84 kilometers per hour on an actual miles driven basis, and 35.36 kilometers per mile as far as displacement is concerned. Just a couple of things to finish up, errors and estimations. First thing is the car clock was analog and had no minute hashes on the face. This meant that the time readings could have an error of plus or minus 5 minutes, depending on how comfortable you feel reading a clock. And then secondly, interesting, the car has some software built into it which estimates the amount of gasoline usage, or really how much gas is left in the car. The miles to E reading was in full miles, meaning that the error was plus or minus 5 miles. For both trips, the car indicated that 16 miles of gas was used, but the trips were actually 18.2 or 18.3 miles. So the difference between actual and estimated could be due to driving conditions, driver ability, quality of the gas, and historical driving practice. Just a couple things to think about with physics, and my car, which I depend on, does a great job getting me there. Thank you so much again for allowing us to take this video. Take care.